Hi, and welcome to this video on mapping attribute clusters. In this video I'll be talking about how we can use the grouping analysis tool in ArcGIS to create groups of similar objects. And when I say similar, we'll be talking about similar in terms of attribute values. So we'll be creating groups of, in this case, Danish municipalities that are similar with respect to a series of attributes such as income, educational level, visits to the doctor, and that type of socioeconomic factors. So we will not be looking at spatial patterns. We'll be looking at, are there municipalities that based on their attribute values are similar. And we will then create these groups automatically and map them. So that's the process we'll be going to look at. If we look in ArcMap, I have this data set here with Danish municipalities, and if I query one of them with the information tool, I'll get a lot of information uploaded in here, some basics, ID and name and so on, the total population, the sex ratio here expressed in percent of females. So how many percent females are there in it? In this case there are 50% females. The coordinates of the center, the average income, annual, total number of legal offences. We'll then talk about criminal offences, sexual offences, violent offences, so, property offences, burglary, etc., and environmental offences. So we have all of these different types of offences. Then we have the population density, so population per square meter. We have our books. This one is how many books does the public library hold per person in the municipality, and this is how many books they lend out per person. Nearest distance doesn't make any sense in this case, but it's a distance to a railroad in Denmark. How many have gone to the gymnasium, so high school or college, whatever. How many have gone to a business gymnasium, so a more business-oriented gymnasium, not the common gymnasium. How many have a shorter education after the gymnasium, so that's typically nurse assistants and things like that. How many have a some bit longer education, teachers, etc. How many have a bachelor? How many have a candidate or master's degree? How many have a PhD degrees? How many or how often do people on average go to the doctor annually? How many percent of the population are on transfer income, also subsidies, grants, etc. And then get some shape information. So that's our data set that we want to look at. And what we want to do is that we want to look at this data set, and then we want to identify groups of similar municipalities. So municipalities that have exhibit the same property values. And there are different ways of doing this. Basically there are two ways to automatically group data in what we call attribute space, so different attribute values. You might not be familiar with the term attribute space. We commonly use it in remote sensing, but basically I have here, if you look at it as just a 2D example, so we have a dimension for each attribute. So here I'm only looking at, let's say, two attributes, the income out of this axis and the educational level out of this axis. Then we have a lot of extra dimensions for each of the properties, attributes we're looking at, but we can't visualize that here, so we'll just look at, let's say, only two. And what we do is that we then start out, we say, I want to create 3 groups. I specify how many groups I want to look at. I give it some seed values. So these red circles here are seed values that specify where we start our group. So this will be a group of high income and medium education, if you wish. This one would be a lower income and also medium education. This one would be a high education and a medium income, if this was the two attributes we're looking at. And then we will group the attributes around these seed values. So that's what we're doing here. These green lines indicate the group borders. So all of these observations that fall here, in this case there's only one, will be a high income medium education. All of the observations here, municipalities in this group, will have a low income medium education, and those up here will have a medium income high education. So that's our first initial groups. What we then do is that we calculate the average or the center, the new center, so for each of our municipalities or our groups here. So our initial value will be moved to a new location, a new center value for that group. So the observation from up here, there's only one in this class, so it moves down to that one. This one stays relatively unchanged, and this one moves a wee bit over towards where we have 3 observations here and only 2 there, so it moves a bit closer to those. So based on our new center points, we calculate which of our new groups the municipalities belong to. So which of our new center points are they closest to? So in this case, we'll get both all of these 3 will be joined into this group because they're now closest to that center point, and this one then loses those points. So this only got those up there, and this one still has got those 5 observations. So based on that, we calculate a new center value for each of our groups. So we move the center value to the new center, and we then assign our municipalities to that center value that they are now closest to. So now we have a group down here with basically a lot of low education. Here we have relatively high income, low education level, and so on here. So what we're doing is that we are refining our groups stepwise, and we continue this iterative process until our groups are stable. Once objects are not changing, or we meet a maximum number of iterations, these models can continue infinitively under ArcGIS iterations, so we put a safeguard value on it. So once it has become stable, or we have met our safeguard value, we stop, and they are now our new groups. So these 3 municipalities belong to this group, and these 4 to this group, and this 4 to this group. And each group will then be similar with respect to these 2 attributes. This approach does not include any form of spatial constraints. We use it, and we sometimes call it the ISO clustering in remote sensing, and it basically just clusters only looking at the attribute value. If we want to say that they have to be neighbors, our new groups have to be spatially continuous, we can't use this approach, but we'll use what is called a minimum spanning tree. What the minimum spanning tree does is that it creates our groups, and our groups are then connected by paths or edges, as we call them, between each of our municipalities. Again here, this is only 2-dimensional, so again you might imagine that we have our attribute to axis again, and again we'll have multiple axes. But this time what we're doing is that these are the ones that are connected together. So we have also this spatial element. What we're doing is that we're connecting the shortest path between each of our groups of spatial connected attributes. And that does to some degree also result in a grouping, but this time a grouping where we have optimized so the path length inside the group, so that is how comparable they are inside the group, is maximized to compare to the path length outside between the groups, and that is what makes our groups become similar. In ArcMap, the tool is called grouping analysis, and together with all our spatial statistic tools, we can find it in our toolboxes. So we'll find our system tools, and we'll go down into this toolbox called spatial statistics, and here we have a set of different tools, and we have one called mapping clusters, and here we have the tool grouping analysis, which is the tool we're going to use. In the grouping tool, what we do is that we have to specify a series of parameters. Of course, primarily we have to specify where we're going to get our data from, which ID do we have, municipality code, specify a number of groups we want to look at, let's say 5, and then specify which attribute we want to look at. Let's say that we want to look at the sex ratio, so percent of females, the average income, criminal offences and violence, so as the two types of offences we might be interested in. How many books do people borrow a year? How many have a gymnasium as their highest education? How many have a business gymnasium? How many have a bachelor and a master's and a PhD? And how many visits do they have to the how often do they go to the doctor? And let's say that's it. I can specify as many as I want, but if I want a nice formatted report, I shouldn't specify more than 15 fields, so I'll stick with these here. I can specify, do I want to create a spatial constraint, so to my groups be spatially connected, and I can do that using different approaches. I just say I don't want to have them. My groups can be spatial discontinuous, and I can also ask it to calculate a optimal number of classes. This one says that it will find use an algorithm to find some seed values to start on, those initial group mean values, and then I can ask it to generate a PDF. I'll just call it 12.pdf, like that. So now I have my nice, this is going to be a nice formatted report once it's finished. So 5 classes, ask it to check for an optimal number of them, generate a report, and have no spatial constraints, and run my tool. So once my tool has finished running, I'll be presented with some form of map displaying my different categories that I have specified. And what's interesting with most of these tools is that you should go to the results window and look at the output you got there. That's common for all of these spatial statistic tools we'll be covering. I've got my results as a tab down here. If you haven't got that, you can go up and you processing choose your results window from up there. What's interesting here is to look at my tool here. It has given me a warning, which is normally severe, but in this case it's just based on my number of classes. I have different outputs. I can go and look at my reports and things like that. Do that in a moment. First of all, we want to look at our messages. We can expand our messages. They can be a bit difficult to read like this, but if I go right click on them, say view, I can have a nice little formatted text to look at of the same messages. So what we have in our messages is that it starts out by doing a calculation of what is the optimal number of classes. It does that by calculating a pseudo F statistic, so testing for the significance of them. And what it finds is that what is interesting in variable we have a optimal value. So there's an optimal value of 2 classes. So if we want to have them, our groups to be as different as possible, we should have only asked for 2 groups. Then we have some decreasing values, and in this case there's basically just a series of slowly decreasing values. There's no real good option here to go for and find, okay, this is the number of classes to use. Sometimes you'll find that there will be a severe drop in this pseudo value at specific values that we can use, and in that case we should use that as our input. But here we just see our values are gradually becoming lower and lower as our class number increases. So there's no good obvious value to choose here. This then tells about what is our mean value and distribution of our values in our classes in general, and that's what we need to know from here. So in this case there was no real good, we could have chosen 2 classes, but there's no really good optimal value for classes. What we then want to do is that we want to look at our output report here. So in our output we have a report. I can see we double click it and it brings us into this PDF document here. And it gives us a short explanation of what we're looking at. So here, first of all, in black, that means that is of the total population, so of all the municipalities. We have a little box viscous diagram here. So we have our, what is our mean, what is our global lower quartile, global higher quartile, global mean. Then later we'll see our, for each of our classes we'll have them in colored on top of them. So first of all, this is for the whole of the country, that's not so interesting. Now we have them for each of our groups. So here we have our blue group here. How does that match our global data set? And it looks relatively similar to the average municipality, if you wish. The red one here underneath has a bit higher criminal data set. The green one here has clearly many more candidates, many more PhDs than the national average, and so on. So this is a description, detailed description of each class. At the bottom of the report, after all of these, there's this diagram, which probably is the most useful one, where we can see our lines, that's our different groups. So we can clearly see that the green ones have lots of more bachelors, lots of more people going to the high school. It also has quite a lot of criminal offences, and it on average has people go seldom to the doctor. This yellow one here, they have quite a lot of high income people, quite a lot of people with a candidate, master's level, and a PhD. And they have quite a lot of females, compared to the other ones. So these are our grouping, and this one is a very good diagram that we might use to explain our groups on our map. So what we do is if we go up and take a snapshot of it, so we'll say take this area here and copy it. So now we've got a copy of this. We can go into ArcMap and say, okay, well, let's make a nice map display. Instead of having a standard legend saying what things are, we will zoom that one down, and underneath it we will place our little legend here. So now we have a map where we can see those green ones, which are basically town areas, and the orange, which is the rich northern outskirts of Copenhagen. The red one are some province towns, and the blue and the green ones, they are agricultural province areas. The blue ones being perhaps a bit more urban in their order. So that's the output of the grouping tool, and of course we can then experiment with which attributes we need to analyze in order to get a good understanding of our data set. So that was it. Bye.